Okay, so we're going to be talking about what is an electromagnetic wave. This is part 3 of our notes on different types of waves. And what is an electromagnetic wave? We talked about mechanical waves in part 1 and part 2, and so we know that mechanical waves must have a medium, but an electromagnetic wave does not require a medium. So what are these electromagnetic waves, and why doesn't it need a medium like a mechanical wave does? Well, an electromagnetic wave is a transverse wave that transfers electrical and magnetic energy. So it's easy for you to know what kind of energy it transfers because if you dissect the word electromagnetic, then that would be really easy for you to think, okay, that's right. It transfers electrical, the electro part, and magnetic, the magnetic part of electromagnetic. This consists of vibrating electric and magnetic fields that then move through space at the speed of light. Okay, so these waves move very fast. Well, how do you produce an electromagnetic wave? Well, every charged particle has an electric field surrounding it, which produces electric forces that can push or pull on other charged particles. So think back to our electricity units. We had talked about how like charges then are attracted, like forces repel each other, like charges repel each other, and opposite charges attract each other. So opposites attract, like charges repel. Okay, so whenever you think about that sentence we just filled in, which that they produce electric forces that can push or pull, okay, your push, that's going to be the repel part. So we know like charges repel, and we know that pull, that's going to be your attract part. And we said that opposites attract when we talked about electricity. So we know that that is what happens when we talk about charged particles. Well, what happens when a charged particle moves is that it produces a magnetic field. Now, if a charged particle changes its motion, then its magnetic field changes, and then it causes the electric field to also change. And also, when one field vibrates, so does that other field. So if one field moves, the other field will move. If one field vibrates, the other field vibrates. That's because these are two fields are intertwined. Okay, the two fields vibrate at right angles. So at 90 degrees, okay, we know right angles, that's 90 degrees to each other. So if you take a look at this diagram, you see that these are transverse waves, okay, because they have crests and they have troughs. We know that the blue wave you see on the diagram is the electric field. Okay, and then at a 90-degree or right angle to the electric field, you also have the magnetic field. So these are just very intertwined to make up that electromagnetic wave. That because if one will move, then the other will move. If one vibrates, it'll cause the other one to vibrate as well. So So how does that all go along with, well, it doesn't need a medium. How does that work? Well, it's all related back to the energy that these electromagnetic waves have. Okay, the electromagnetic radiation is the energy that is transferred through space by electromagnetic waves. Okay, the electromagnetic radiation is what allows these electromagnetic waves to not have to have a medium like a mechanical wave must have a medium. Okay, so because it has the electromagnetic radiation, it can travel through space. Okay, so electromagnetic waves do not require a medium. So they can transfer energy through a vacuum or empty space. And that is how the light of the sun and the stars can reach Earth from space. Okay, the next part is speed. And one of your learning targets is to compare the different types of waves with their properties of speed, wavelength, amplitude, and frequency. So now here we are talking about the speed of electromagnetic waves. So all electromagnetic waves travel at the same speed in a vacuum. And that's about 300,000 kilometers per second, which is called the speed of light. Okay, at this speed, light from the sun takes about 8 minutes to travel the 150 million kilometers to Earth. So this moves very quickly. These waves move very quickly through the vacuum of space. Well, what is the electromagnetic spectrum then? You might have heard that before. When we were talking about different types of energy, we mentioned the electromagnetic spectrum. So even though all electromagnetic waves travel at the same speed in a vacuum, they still have different wavelengths and different frequencies. Okay. Even though they all travel at the same speed, they have different wavelengths and different frequencies. Okay, the electromagnetic spectrum is a scale that's really showing you the complete range of electromagnetic waves placed in order of increasing frequency. Okay, so visible light is the radiation and the wavelengths that your eyes can actually see. Now, only a very small portion of electromagnetic radiation is visible to the eye. So only a small portion of electromagnetic radiation is visible light. The rest of those wavelengths are actually invisible. Now, because the speed of electromagnetic waves is the same, because the speed of all electromagnetic waves is the same, As the wavelength decreases, then you will know that the frequency will increase. Okay, so the shorter your wavelength, the higher the frequency of your waves. So if we're drawing our transverse waves over to the side, we know that if we have a transverse wave where your wavelength is a little bit longer, okay, then your frequency isn't as high. Okay, but we'll draw another transverse wave where the wavelength is shorter, and we can see that because the wavelength is shorter, it's also causing your frequency to increase. So waves with the longest wavelength have the lowest frequency. And waves with the shortest wavelengths have the highest frequencies. Say frequencies. And the higher the frequency, the higher the energy is. Okay, so you can see that here's the electromagnetic spectrum. Okay, we start off with our radio waves here with long wavelengths and low frequencies, and then it continues until you see your gamma rays with very short wavelengths and the highest frequency on the electromagnetic spectrum.